Today I want to go over the question of which is larger, this number to some ridiculous power or that number to a ridiculous power. Before we do that, I'm going to do a quick warm-up problem of what we did in the last video. I'm just going to run through this just so you guys can follow along and get some more practice. So the question is, what's the prime factorization of this ridiculous expression? So step one is break everything down. So notice, what do they all share? They share 3's as their building blocks. So this is 3 squared to the 40th plus 3 cubed to the 27th, and 81 is 3 to the 4th. All right, step two, let's apply a power to a power. So that's 3 to the 80th. We multiply all of them. 3 to the 81st, and 3 times 19. I'm not even going to multiply that, I'm too lazy. That's just going to be 4 times 19. That's going to be 4 times 20, and step back a 4 to get 76. All right, so now we're at this point. What do all of these share? They share 76 3's. So we're going to factor, so from this step we're going here. We're going to factor out 3 to the 76th from each of these 3. So what's 83's divided by 76 3's multiplied? We're left with 4 3's, because these two multiplied back get you 80. So 3 to the 76th power, if you take that out of 81, we're left with 5, because these two exponents add up to 81. And that's right, you guessed it, it's 0. So 3 to the 0th is 1. So a number divided by itself is 1, so that's 1. Okay, so now this is garbage. This part is still ugly, but it's already 3 to a power, so this is part of the prime factorization. And luckily this is not too large, so we can calculate this. So this is 81. If you've been practicing your powers, this is going to be 1 extra 3 times 81, so that's 243. 81 times 3 is that, minus 1. All right, so let me be lazy. First I'm going to chop off these 1's, so that's now an 80. And then I'm going to add, so that's 323. Now, is this number prime? I don't know. Let's check. 2, no. 3, no. The sum of the digits is not divisible by 3. 5, definitely not. 7, so that would be what? 280 and 43, so nope. 11, nope. 13, 260, 63, nope. 17, 289 is 170, okay, 170, and that would be 153. Well, let's see, maybe 17 does work. So 17 times 10 gets you 170, and then 153 divided by 17. Notice this is, if you add 17, you get 170. So if you step back 1, 19 should work. Another way you could see this, if you've been practicing your perfect squares, this is a little advanced, but 18 squared is 324, and this minus 1 gets you 323. So if you've been practicing tricks 1 and 2, I won't go into it too much, but if you know this and tricks 1 and 2, you might have been able to see this a little faster. So bottom line is, this whole thing is now 17 times 19. So the answer is, all right, so this is a little involved, but just to practice the previous technique of factoring. All right. So now, how do we solve this problem? 2 to the 200th or 3 to the 150th, which is larger? So on the one hand here, the base is smaller, but the power is larger. The base is larger, but the power is smaller. So to me, it's not obvious which one of these is larger. You kind of have two effects. Now, if this one said 3 to the 200th, then clearly 3 to a larger power is larger than 3 to a smaller power. So that would have been obvious. Now, this is really crazy, so our job is to make this look less scary. What is 200? We can break it out this way. It's 2 to the 20th raised to another 10th power. And this can be thought of this way. Why did I decide to do that? Because what this allows us to do is to realize whatever's going to be true here is going to hold if we raise both of these to the 10th power. In other words, if I'm larger than you are and we double both our sizes, I'm still going to be larger than you are. So we can ignore the tens. Or in the original, basically we're just chopping off these zeros. So now we're comparing 2 to the 20th and 3 to the 15th. These are still scary, but they're much better than these original numbers. Okay, now let's see, well, these share 5s. So we can do this. 2 to the 4th to the 5th, and this is 3 to the 3rd to the 5th, because these powers multiplied are 15, these are 20. So again, we're raising these to the same power, so we can just ignore it. Because whatever holds here, if this is larger than this, then raising it to the 5th power will not affect anything. So now this we can calculate. So that's 2, 4, 8, 16, and this is 27. So the winner is 3 to the 150th power. So the basic idea for these is break them down till they're manageable. So let's try this one. This one's a little trickier, but not much. So by now you guys should realize, let's just chop off these zeros. And then let's find the GCF of 20 and 12. So that's 4. So we're going to do 5, put the 4 on the outside. 3, 4, we can get rid of these 4s. And so let's replace the original problem with this. And now what we're going to do, it's still not obvious because this number is larger, but the power is smaller, so we can't really tell. The bases themselves have numbers in common. So specifically, a 12 is a 4 times 3. And a 20 is a 4 times 5. So let's apply this over here. So it's 4 to the 5th times 3 to the 5th, and this is 4 cubed times 5 cubed. Now, since they both have at least 3 4s, let's get rid of this and shrink this down to a 2. In other words, I subtracted 5 minus 3 because we took away 3 4s from each of them. So now already it's looking more manageable. Do we want to try to calculate this? I guess we could. Yeah, why not? Okay, so at this point, 5 cubed is 125. And let's see what this is. 3 times 3, 4 times is already 81. So this is going to be 81 times 3 times 4 squared. So I won't even bother doing that. You could tell this is going to be larger.